All right, guys, I'm going to go over the first 4 problems of our flipbook in case you were struggling with that. So remember, these are Pemdas problems. So the biggest concept that I'm going to start with is that, remember, order of operations, but we are going to go in reverse to solve. Remember, that means I'm going to start and look for subtraction. If I see subtraction, I do addition. If I see addition, I do subtraction, and vice. Then, once addition and subtraction are gone, if I see division, I use multiplication to get rid of it. If I see multiplication, I use division to get rid of it. We'll talk about it later, but exponents, we use this thing called a radical. We're not using that right now. And we'll go from there. So, number one, the first thing I'm going to do is make the parentheses go away because I am not ready to solve. Remember, the big thing for this was this supposed to be one variable. All right? One variable. So 9 is going to go. I'm going to use pizza delivery guy. Remember, that's a distributive property. So 9 goes over to 1. That's going to be 9 minus 18x equals negative 3x plus 1. Now, I still have 2 x's. I like to move the smaller of the 2 x's. So I'm actually going to add 18x to both sides. I end up with 9 equals 15x plus 1. Now I'm just going to do the order of up. Now I'm finally allowed to solve. So the first thing I'm going to do is I'm going to look for subtraction. I did not see any. So I see addition. So to get rid of that plus 1, I'm going to minus 1 from both sides. I end up with 8 equals 15x. So there is no subtraction. I just got rid of the addition. There is no division. I do see multiplication. So to get rid of that multiplication, remember that's the 15 in front of the x. I divide both sides by 15. So my final answer, and I'm going to just leave it as a fraction, is x equals 8 over 15. Right, and that's it. Number 2. Very similar concept. Once again, there's multiple x's going on. My recommendation for you guys is to make sure that you do not try to get rid of this this fraction by multiplication to start, because of the stuff on the right side is going to get kind of messy. And sometimes it actually gets a little bit easier if you just try and multiply it through. So the first thing I'm going to do is I'm just going to distribute this negative 3/4. All right, so I just do negative 3/4 times 16. So remember, you're doing negative 3 times 16 to get negative 48, then dividing it by 4, or you're just doing the fraction together, negative 3abc 4 times 16. You end up with negative 12x. So notice it makes your fraction go away without having to multiply by anything. And same thing when I do negative 3/4 times 8. So you can either do 24 divided by 4. If you're going to multiply 3 times 8, you have to divide by 4. I'm just going to do negative 3/4 times 8 to get negative 6. And then 19. Nothing happens with 19 here. Now remember, the minus sign does the distributive. So not 19, the minus sign by itself. If you have to put a little 1 there so you don't forget, to get minus 10x. And make sure that you take the negative 1 to both the 10x and the negative 3. It's the most common mistake. You might have seen it. All right. Now I'm going to combine like terms on the right side. I can't do anything on the left side, so I have negative 12x minus 6 equals 19 and 3 is 22. So I have minus 10x plus 22. Now I still have x's on different sides, so I'm still not on the solve part yet. So I'm going to move the 12x over because I think that's easier, because it's negative 12 is a little bit smaller than negative 10. So I end up with negative 6. If you added 10x to both sides, that's fine as well. Negative 6 equals 2x plus 22. Now we're finally allowed to use Pemdas backwards. So now I'm going to get rid of the addition. So to get rid of the addition, I subtract 22 from both sides. I end up with 2x equals negative 28 Now to get rid of that 2, I divide both sides by 2. So my best answer is x equals negative 2. I don't know why I wrote negative 2. It's terrible. Negative 14. Right? And that's it for number 2. And if you're not sure, you can just check your work and you'll end up getting 162 on both sides, which I did. So, all right, same exact concept. Remember, if you're struggling, this is where you're going to use every single time. You're going to use Pemdas in reverse, Pemdas backwards if you're struggling. I mean, that tells me you're struggling, all right? But remember, before we can do that, we have to have one variable. On this problem, I have 3 variables going on right away. So the first thing I'm going to do on number 3 is I'm actually going to do 2 things at once. I'm going to multiply both sides by 2. So multiply both sides by 2 because I want to get rid of this fraction right here. The other thing I'm going to do is I'm actually going to distribute just to save me some space. So I'm going to do the distributive property here. So pizza delivery guy right there. Remember, that's a little -1 if it's bothering you. So remember, the reason I chose to multiply both sides by 2 is so my life's easy. So those cancel. All right? Don't try to multiply everything on top by 2 because that's going to make your life harder and it's kind of defeating the purpose. So the left side's going to become 5x minus 18 minus x minus 9. So the -1 goes to both the x and the 9 equals, now 2 times 3 is 6, 2 times -4 is minus 8x. Don't make that common mistake of forgetting to multiply both. Don't let your pizza delivery guy get fired, right? Now I'm going to combine like terms on the left, so I have 5x and -x, that is 4x. -18 minus 9 is minus 27 equals 6 minus 8x. I still have 2 x's, so I'm not ready to solve yet. I'm going to add 8x to both sides because it is the smaller of the 2 x's. So I end up with 12x minus 27 equals 6. Now I'm going to add 27 to both sides now, because now I'm finally on the solve part. So now that I'm on the solve part, I get rid of the subtraction first. I end up with 12x equals 33. Now I divide both sides by 12. So I'm going to get x equals 33 over 12. Now both of those can be divided by 3. So if you use my calculator, you can just do 33 ABC 12. It'll give you a mixed number. You can give me a decimal. I'm going to divide both sides by 3, and I'm going to get 11 over 4. So I'm going to get x equals 11 over 4. But 33 over 12 is a really good answer. It's just not the best. Now we're moving on to number 4. Number 4, if you're struggling, remember that is the time we use cross multiplication. And really, I don't really call cross multiplication because I don't want you to think you can do that all the time. This is the only time you can use cross multiplication is you have exactly one fraction equal to another fraction. So I'm not solving because there's variables on both sides. So the first thing I'm going to do is I'm going to multiply both sides by 7 because I want to get rid of this 7. And then at the same time, I'm going to multiply both sides by 3 because I want to get rid of that 3. Now, the 7's cancel on the left and the 3's cancel on the right. So it just becomes 3 times 4x plus 1 equals 7 times 2x minus 1. So I'm going to distribute. I'm going to get 12x plus 3 equals 14x minus 7. I'm going to move the 12x's over because they are the smaller of the two. I'm going to end up with 3 equals 2x minus 7. I'm going to add 7 to both sides. I'm going to get 2x equals 10. Divide both sides by 2. X equals 5. And that's it for the first 4 problems. Look out for one mistake in those 4 problems. Because some of our classmates were out on the day I went over Firestarter 7, where some were behind because of field day and stuff like that. I am going to go over Firestarter 7 as a video as well. So remember, there's properties we talked about. We said if x if they're the same base with exponents, we add the exponents. We said if it's an exponent to an exponent, you see parentheses, you're going to multiply those exponents. If you see an exponent over on top of an exponent, so you see a division bar, so if you're dividing exponents and the bases match, it's a big key, you subtract them. We talked about if you had a negative exponent, that's like somebody didn't pay their rent, they got to go to their mom's basement. You just move it to the other side of the fraction. And then anytime any exponent to the 0 power is always 1. So like number 1, the first thing I'm going to do is I'm going to use this property in number 1, and the little 3 is going to go to the -3, to the 4, and to the 2. The mistake I see is people do -3 times 3. -3 is a big number. Remember, there's technically a little number 1 there that we don't write. So exponents, little numbers always go with little numbers, big numbers with big numbers. So I end up with -3 to the 3rd. 4 times 3 is 12, so that's x to the 12th. 2 times 3 is 6. Technically it should be in parentheses, it won't matter with odd exponents. -5, x 12, y to the 6th. Now I do -3 to the 3rd, I get -27. So this piece right here turns into -27 because -3 to the 3rd is -27. Now, because these are exactly the same, because this is the exact same as this, that should be a 12 there, I forgot to write it. Because those are exactly the same, you combine the big numbers. So I do -27 minus 5, I get -32. And it's a like terms problem now. So the exponents don't change. So exponents do not change when we add and subtract. Exponents do change when we multiply and divide. All right? So that's what you got to remember. That's it for number 1. Number 2, same exact concept. 3, now remember there's a little 1 here with 6. So that little 3 goes to the 6, but not the big number, the little exponent. So little numbers with little numbers, big numbers with big numbers. So I end up with 6 to the 3rd, m to the -9th, times m to the 5th. Now these are on top of each other. So that's this property right here. So I'm going to do 5 minus 3 to get m squared. Now 64 is not affected, so it stays on the bottom. All right. Now what I'm going to do is these guys are next to each other, so I'm going to add the exponents. And 6 cubed is 216. So my next line. So 6 cubed is 216. So this piece right here turns into 216. The m next to the m, that turns into m to the -7, and 64 is on the bottom. Now, since we're not allowed to have a negative exponent right here, this is this property, that m is going to go downstairs and live with 64. 216 doesn't have to move because it doesn't have a negative exponent. It technically has a little 1 there. So the best answer for this one, well, not the best answer, the next step is going to say 216 all over 64 m to the 7th, because now that m is positive. So if you're not sure how to simplify the fraction, you could divide by 8, both sides by 8, right? I'm going to get 27 over 8. So the absolute best answer for number 3 is 27 all over 8 m to the 7th. Okay, that's it for number 3. Now the last 2 are probably the easiest. So actually, the number 4 is definitely the easiest. Right away I see matching bases. If the bases match, we only care about the little numbers. We add them up. We end up with m to the 5th. -4 times -3 is -12. Done. See, that was the easiest one. Like I said, my kind of brain likes to do all the easy steps first. So I always look for this rule first. I always look for this rule first because I think it's the easiest. So if I can do that rule first, I always do it. And I always look for this rule second, because if I can do that, it makes my life easier. That's kind of what I'm going to do here in 5. So 5. So C with C, that gives me C to the 6 because they're right next to each other. Remember, there's a little 1 there that we don't write. And I can't forget to do negative 3 times 2. I actually did this once and I forgot to do negative 3 times 2. That's minus 6C to the 6th. Now look, I have C on top of C. That's also C to the 6th. 28 divided by 7 is 4. We are subtracting now. Since we are subtracting, we do not change any exponents, and we only can put them together if they're exactly the same. They are C with 6, C is 6, 4 minus 6, negative 2, C to the 6. That's the best answer.